moving on to page 52 of the notes, we're starting to get some code here that's actually quite useful. There's a file called Celcius.c. Now, for us to be able to run this, the first thing we've got to do, same as we did before, so we've got to go to the folder where we're running all our code, and inside here, same as before, I create a new text file, and I'm going to call that Celcius, and click away, and you can see it's a text file. Now going to open it, save it as all files, and I'm going to call it .c. If you try and do it other ways, you may run into a few problems, so that's why I'm doing it this way for you. And I don't want that file called Celcius anymore, so that's gone. So, as before, I'm going to cut and paste all of the code, hopefully, and I'm going to put it into Celcius.c. Okay, I'm going to hand over to Mike now because he's the one for the formatting of these things. So we copied our code across. It looks pretty untidy, quite difficult to read. Mike talks through that.
Okay, let's see what we have here. We still have our standard IO inclusion there. We have a couple of constant definitions here using the
We'll talk about those shortly,
we come down to our main. Let's indent all of this. It's very good to format your code like this, especially when you're submitting code as an assignment.
Yes, because you get more marks if the person marking it can actually read it, don't
Exactly. Okay, so let's have a quick look at now. We've introduced a new variable called float, which
so a floating point number.
It has a decimal place.
Yeah.
It has a decimal place. Could go into the details of how it's never an exact number. But
sort of 3.14 or 2.71 or 9.9387654, they're all floating point numbers. 1, 10, 100, 1,000 are all integers,
yeah.
right?
You might find that if you type in 2.65 something or 2.652, it's actually stored in the computer as 2.6519729453. Because it's an approximation, but
okay.
That's for another.
But we don't need to worry about that.
So when we're using floats, we want to represent a dot something after a number. So our scanf and our printf statements need to use the new place.
So it's not using a D anymore; it's using an F.
An F. Otherwise, if I put D in there, then you would get incorrect representation of the variable.
So if I type 10.44, it would just probably do 10 without the 0.44.
If you're lucky.
If you're lucky, otherwise it will give a compiler error.
Yeah. And now we're using these constants that are defined up here to do
talk about those in a minute. Let's, and then printing it out. Right?
And what is interesting here is again we've got a %f, but we've got a 0.1 in the front.
What does that do?
What that does is that specifies how many decimal places we want to use. So if I didn't have that, I would end up with something like 3.69244268. You know, really long.
Percentage precision. So, well, let's change that because one decimal point. I never have like one decimal. Let's make it 3 decimal points.
3 decimal points. Okay.
Okay. Right. Let's try and run that code now.
So it's called Celcius. So if we do a GCC, our output file is Celcius, and we'll compile
Celcius.c.
Celcius.c.
Moment of truth. No errors. Look at this.
So let's run it. Celsius. Enter Fahrenheit.
Enter Fahrenheit. Well, let's go for 112.
112.
So 112 is 44.444.
Notice we have 3.
Because we set the 3 here.
Let's just try it without having that in there and see what we get. So for the same.
So that should be the whole number, shouldn't it? So I guess it would just be 4 recurring, right? That would be my guess.
Okay, so we'll type in 112 again.
Yeah.
See?
Oh, okay, yeah,
See
we
how
do
I
have
get
around
a bunch more. So, and if we change that to 0.1 again, the one that you don't like, sorry, I've put that in the wrong place. We need it to be there. %.1f.
Yep.
It's important that you get that in the right place
Yeah,
between the percentage and the F.
And the backslash n is just creating a new line after that.
112, and there you can see I get 44.5.
Yeah.
Okay, one interesting thing, let's change it to a D and see what we get. Yeah?
Well, I would
Percent
suspect
D.
you'd only get the whole part, the integer part, or an error from the compiler. I don't know which one it's going to do. Yeah. Just talk me through that then.
Reason for that is because the way a floating point number is stored as bytes, consecutive bytes in the memory of the computer, is completely different to how integer is stored. And what that placeholder is doing is telling the compiler how the variable is stored. So how the function needs to organize the bytes to show you the correct number.
So the ones and noughts inside the computer, the way in which they're organised actually has significance to us when we're running high-level code.
Absolutely.
Clearly, that's the wrong answer, isn't it?
Massively.
Celsius equivalent is minus several billion, and that's just simply not the right answer. And it's as simple as that percentage D or that percentage F.
Yep.
So we've asked it to convert to something that it can't do. Well, it can do, but that's the numerical answer.
It can convert it, but it has to follow a specific set of rules. A floating point has a mantissa and an exponent part, and it's stored in memory in a certain order. Integer just has bytes stored together, depending on how big that integer is. And so the compiler needs to know how to reorganize that information in memory to show you the correct value. And what we've said here is we're storing our values, a floating point, a mantissa, and exponent, but we're telling the compiler to show it as a sequential byte
But
pattern.
it's an integer with no
Never work.
mantissa, right. So let's just mend that. I don't like broken code. Let's do it 2 decimal places.
Yeah, there's also another interesting thing here. If we put a 0 in front of this, so it's 0.2, what do you think that would do?
I'm not sure at the moment.
Can you give me a Fahrenheit temperature that would give me 0 point something as a result?
40.
40?
Yeah.
Yeah? So if I now type 40 in there and have a look, no, that gives me 4.44. What I want is something that gives me 0.44. You think you can do that?
No.
Let's try 22, see what that gives us. That gives us a -5. So let's try 32, see what that gives us. 0.00.
Yeah.
Okay, that's great. So if I look at that 0.00 there, if I take that 0 off there and just have that 0.2, and now
I know what it's going to do now. It's just going to print.
so what was the 32 is the value, isn't it? 32. Interesting. Exactly the same. So what's happening?
So this is the smart compiler now, isn't it?
This
Because you
is
would have
very
expected that
smart.
0 not to have been.
Yeah, I would have expected that.
Okay,
0.
well, not to worry.
Or that 0 not to have to have been on the end points.
Yeah.
You know.
Okay.
But that's definitely one to.
Could catch you out that one.
Yes, that could catch you out. That one. Yeah.
Okay, let's talk a little bit about the code because the new content here. So we've seen scanf before. We know how to do numeric calculations here. So we've got Fahrenheit minus, now there's something in capital letters here which is new to us, and the scale factor here which is in capitals, but this isn't a variable, is it? So freezing point isn't defined here inside May, so it's outside the scope of that. This is straightforward, so with the print statement we're used to, we've got a backslash new line, we've got formatted output, which we discussed just now. We're printing Celsius and we return 0 once the code is finished running. But this is new. Talk me through this, Mike.
What we're doing here is we're defining some constants, some values that cannot change or be changed. So in our source code, what we're defining a label. It's not a variable, it's a label.
It's a fixed thing,
It's a
so at
fixed thing.
runtime that cannot change.
Cannot change, we cannot change it, and it cannot change. Let's have a look
So
at
why
that.
would you do that?
Why would I do that? Because there's a constant. I don't want the source code to ever change it, even if I forget or accidentally change it. I mean, for example, let's try and change it. Let's put a piece of code in here, right, that assigns the value freezing point of 10. Yeah? If this was a variable, that would be completely valid. but it's not. It's a constant. So
Yeah.
let's try and
So
compile
we should
that
get
piece
some
of
red
code.
ink now, shouldn't we?
We should do, and we do.
We do, yeah.
Where we can see here is L value required is left operator as assignment. It will not allow me to change the value
Because
of
the
that.
hash define has said that it's constant.
Yes, it will not allow me. It would always have that value,
Yeah,
regardless.
yeah.
Yeah, and we can we can look at that. If I put a printf statement in here,
Mhm.
and on that printf statement, I just show what is it? Is that a floating
Floating
point?
isn't it?
So we show a floating point, and I just want to see what the value of freezing point is.
Yeah.
Yeah.
32, isn't it?
We know it's 32, but I just want to double check it. So now we run that piece of code, and look, we can see there 32.00000,
Yeah.
right? All those
And we
lovely
could format
zeros.
that.
We
if
can
we wanted
format
to
that,
1
and-
0 or 2 zeros.
And notice how this horrible alignment
Yeah,
here.
that's because we didn't have the.
It's why. It's because if we had that in there, that escape character, and we recompile right there. That's much nicer, isn't it?
Yeah,
Yeah.
that's good.
So we
And
can.
I noticed in that second statement there, so I'm happy now that if it doesn't need to be capital letters here, does it? But it seems to
Convention.
convention. So convention says that if it's constant, it's all uppercase.
Yeah.
But I could write it lowercase, but I might get confused with the
Could do.
variable. So
You could do. And
So
you
it's-
can't now call a variable that name.
yes, okay, I understand that. But on this second one here, look, something funny's going on here because we're saying it's constant, but you're doing a calculation.
Yeah, I am. I'm doing a calculation, and it's completely fine. But what will happen is the scale factor will just have the value, retain the constant value of the result of the
Ah, I
calculation.
see, because 5 over 9 is always going to be 5 over 9. It
Yeah.
can't change.
Yeah, and these defines, and when you put a calculation, they are dealt with by the preprocessor,
Yeah.
not the compiler.
Yeah,
And that's where this F comes in. I'm telling the preprocessor that I want this number to be dealt with as a floating point number.
yeah. So if on that second one there, instead of this being a fixed number in here, I know it'd be difficult to do, but if I made that a variable, that wouldn't be allowed, would
No, because that couldn't be asserted to be constant. Because
Yeah.
the variable
Yeah.
could change, and it's a variable. That's why it's called a variable. That would not be allowed. You can only put a constant or a mathematical equation that all the values are known.
Okay, that's a really useful piece of code, that, and we're starting to get quite advanced now, aren't we? So that's it. That's Celcius.c on page 52 of the notes, section 1.